Hello, everyone. Glad to see you here, considering what's going on in the other rooms. And thank you for choosing to come to my talk. My name is Milen Dyankov, and I'm going to be talking today about what's not new in modular Java. And speaking of which, did you try modular Java 9 already? How many of you have? No one. Wow. And did you attend the sessions about Jigsaw and modularity? Okay. Most of you. Okay, good. How do you like it? Who is impressed by what's going to happen in Java 9? Oops. Okay. Now I understand why you're here. Okay, we're going to be having a slightly different look at modularity in Java in general. And when I say not new, a lot of people are confused. So what do you mean not new? It's a whole lot of new stuff going on in Java 9. That's absolutely true. And if you think about all the frameworks, all the implementations, and all the details, there's a whole lot of a new thing going on there. That's not what I mean. When I say not new, what I actually mean is not new in terms of a concept. In terms of a concept of modularity, the way you apply modularity to Java applications, and the results that you get out of a modular Java application. Before we dig into that, though, let's answer this question, why it is important to talk about modularity now. And you probably noticed it already that, I think it was like 4 sessions on modularity in Java already, and roughly the same amount of sessions last year. So this is the evidence that I could find about the attempt to modularize Java. This goes back to year 2005 with JSR 277. Actually, I believe there was an attempt even before that, but for some reason I couldn't back up that information with any valuable source. But it wasn't before 2014 when JSR 376 showed up, when the whole thing about modularizing Java becomes serious. And we were expecting it to appear year after year, month after month. This is from DevOps last year. And this is the question someone put on the table, on the whiteboard. Will we use Jigsaw in 2016? And as you can see, they got it right, whoever answered that. But I like that sentence down there, which says, you can pry OSGI from my cold, dead hands. And trust me, I wasn't the one who wrote it. By the way, if one of you wrote it, come see me after the talk. And the reason I'm showing you this is because I'm going to have a lot of references to OSGI just to show you some of the concepts and how the different problems were approached over the years and what worked and what didn't. As you can see, and you've probably noticed that Java is modularity in Java 9 is so important that Oracle is postponing the release of Java 9 because of Jigsaw, and they've done it actually twice. This was for March, now it's July. And I wouldn't be surprised if that happens again. And that's not to say that's something wrong with Oracle, just modularity is really hard. It is not a trivial task. And it just takes time to do it right. So I'm totally not surprised by these delays. The question, though, is what is modularity? When we say it's complex, it's this and that, but what actually we mean when we say modularity? And here's the tricky part, because this is where the quote from Alice in Wonderland comes in place. When I use a word, it means just what I choose it to mean, neither more nor less. So when we say modularity, it means whatever we choose it to mean. There is actually no a strict definition of modularity. I mean, you can do the exercise and go to some, dictionaries or Wikipedia, or you'll find a whole lot of definitions of modularity. There is not a definition of modularity that everyone in this room will agree with, and so that we have a common understanding of what modularity is. And that is indeed a problem. So back in 2011, Dr. Graham Charters proposed a modularity maturity model. Now, those of you who are familiar with how maturity models in general works may kind of recognize the same thing here. We have like 6 levels of modularity. And the first is ad hoc, meaning you have nothing, no modularity at all. The second is decoupled from artifact, means you don't really care about who brings modularity to you, but the modularity itself. Then it's actually modularity when you decouple yourself from the identity of the thing. Then you go one step further, which is loose coupling, devolution, and dynamism. And I'm going to go in details in a few minutes. So this was the original proposition. And I think now when you just read the titles, it doesn't really make immediate sense what it is. If you start actually go and see the presentation and dig into the details, it starts to clarify like what exactly it means. Actually, that's not quite correct. He introduced level 7, which is called Peter Kriens, and it's only available for people who are Peter Kriens. And if you don't know who Peter Kriens is, that's probably the most knowledgeable person on earth as far as modularity is concerned. So Peter Kriens didn't stay quiet on that. And in the foreword of a book called Java Application Architecture, actually referred to that modularity maturity model. And he said, well, if I were to do it, I would redefine it. I would just use 5 levels, and I'm just going to call them unmanaged, managed, proper isolation, minimized coupling, and service-oriented architecture. So when I was preparing this talk, I was like, which model should I use? How do I explain it to people? And I was like, okay, I'll go with my own, which I call buzzword-compliant modularity maturity model. And the reason I come up with this is because from my observations from the last several years, this is how we do programming today. It's buzzword-driven. We come to a conference, someone tells you this is the technology that you should be using, you go home so excited, and next thing you know, it's in your portfolio or in your company or something. We are heavily buzzword-driven whether we want to admit it or not, especially with the microservices and containers hype. Don't try to convince me that's not the case. So here is your buzzword-driven modularity maturity model. So level 1 is the monolith, the bad guy. Anyone doing monoliths? Wow, brave people in this room. Okay, so the monolith is the bad guy, and meaning you build the whole thing together, and you're totally unaware of your own dependencies because everything's in the box, right? So you put it in the box, it's there. Now, you can go one level up, and you can say, wait a minute, I actually want to split things. I want to have multiple pieces that are independently deployable. And this is where you come, or well, not independently deployable, but independent of each other, whatever in that particular case independent means. So you split things apart, and you call them modules. And now that is the time where you become aware of your infrastructural dependencies. So you basically know this artifact can only function if this other artifact is present. Okay? Well, how it's present, that's a different story. Typically, it's probably putting a jar file on a class path or things like that. Now, at level 3, you want to be aware of functional dependencies. So you are not actually saying, I need a module of that name, but basically you say, I need someone who can do this, right? And then there is something, right, a container or something, some kind of abstraction that can tell you, well, yeah, I can do that. And then you depend on that thing, but then you're still coupled with the implementation of that thing. Now, level 4 is the discovery level, where you actually go even one step further in the abstraction, and you basically say, now, I don't really care who, as long as someone does this thing, and I can delegate that job to that guy, I'm good to go, right? And this is where you don't really care about what is it around. You don't really care whether the artifact is there, whether this class is there. You're basically saying, I need someone to be able to do this thing. Go find one for me, okay? And level 5 is when you basically decouple yourself from time. And by that, I mean decouple yourself from change. You acknowledge the fact that your situation of today is your situation of today. It's not necessarily your situation of tomorrow. Tomorrow things may change, and you're prepared for that. So you design your dependencies and your requirements in a way that when requirements change tomorrow, you can actually easily adapt to the new situation. So with that in mind, how do you do things like modularity in Java? Level 1, well, that's Java. There's nothing fancy in here. To do composites, we typically use Maven, and I don't mean the Maven as a build tool, but Maven as a repository of artifacts. So we basically just say, yeah, go grab me this jar file, and I depend on that one. To go on more abstract level, you're probably going to use things like CDI, or Spring, or Java EE, where you actually now you're not expressing dependencies between artifacts, but you're now expressing dependencies between components. This component requires that component, and at the end of the day, you still need to do the wiring with the artifacts, but you are like one level higher in the abstraction logic. Now, anyone willing to take a guess what gives you level 4 in Java? Not surprised, because there is no technology that gives you level 4, as far as I know. The only thing that gives you all the levels, up to level 5, it's actually OSGI. At the moment, that's the only technology I know of that allows you to do all these things. And yeah, I'm not aware of every single technology that exists, so there may be others that I'm not aware of. But the most popular one, as of today, is basically OSGI. And I know what you're thinking, it's scary. No, I'm not going to be convincing you to use OSGI, but I will be using OSGI as a reference because OSGI has been around for over a decade trying to do these things, and during the years has encountered a number of issues and has had to deal with those issues. And when we now introduce modularity in Java, we pretty much face the same issues. So the purpose of this comparison is not to tell you, oh, this technology is better than that technology, but basically to show you how two different technologies approach the exact same problems. This is where your JSR 376 or JPMS or Jigsaw, whatever you want to call it, fits in. So it's kind of a little bit here, a little bit here, a little bit here. And you may wonder why is that. And the reason was a decision when this project started that it needs to be simple. It needs to keep things as simple as possible. So the whole-blown modularity was not an option. So let's look to those things in a little bit different perspective, from application perspective. That thing is your application. And what you see inside, those are your classes. And as you can see, they nicely cooperate with each other. Oh, actually, that's a lie. That's not your application. Your application is more like this. So down there, you have a bunch of classes that actually come from the platform. You have a whole lot of libraries in the middle. And up there somewhere is actually your application. And it's a big mess of classes. That's what it is. So years and years ago, this thing called OSGI came around and said, well, let us solve that problem. So what we're going to do? On a platform level, there's not much we can do because we don't own the platform, right? We just run on top of the platform. So there's nothing we can do with the platform itself. But there is this thing called class loaders. So if we could actually jump on those class loaders and manage the way they load classes, we can actually build the whole stack up in a much, much better way. So this is where it comes a dynamic multi-layer modular architecture known as OSGI. Now, the question is, and it was meant for applications. That is an important thing to remember here. The whole idea of OSGI was to give you a framework or a concept to build applications. It was never the goal of OSGI to modularize Java as a platform. So it wanted to give you something to build modular apps. The question is, what do you do with this middle part? And everyone optimistically decided that since OSGI is so easy, everyone should be building bundles, which is the name of a module in the OSGI world. And if you've done any OSGI development, anyone doing OSGI? All right, several people. If you've done OSGI development or you do OSGI development, you know how well that turned out to be. There's a bunch of libraries out there that never actually became a bandos, and it's a big issue with trying to make them proper modules. So this is where OSGI ended. And this is a quote from Peter Kriens again, which says that many people claim that OSGI is hard, and then actually don't realize that what is hard is a modularity. And I highly agree with that. And actually, you observe that today when people start doing things with Jigsaw. They are like, hey, we built modular application all these years, and now they don't work with Jigsaw, because when Java itself started to enforce the exact same constraints, conceptually same constraints, it turns out their applications still don't work the same way they didn't work with OSGI, except before there was OSGI to blame for that. And now it's like, you can't blame it on Java, right? Because obviously Java is doing it right. So this is how GSR 376 or Jigsaw or JPMS want to solve the problem. Well, they own the platform. So modules are now first-class citizens, which is a good thing, honestly. Now the fact that Java itself has a notion of modules, it's a much better world. The problem becomes right up there. Because all of a sudden, you are asked to do modules in your applications. So let's get back to the thing. When the GSR started, the goal of that GSR was to modularize the platform. The goal of that GSR wasn't to provide a environment or a tool or a library for building applications on top of that platform. That kind of came up as a, I don't know at what time exactly and how, but that evolved from modularizing the platform. Once modulars were in platform, all of a sudden someone decided that that's a good idea to actually build applications that way. Okay, so it's not, okay, I've been criticized for this slide because it's not really that you have to, you must use modules. There are obviously ways to not do that, but the reality is, sooner or later, you will be forced to do it because of the whole environment around you doing it. And the same thing applies for libraries. Now, all libraries needs to be modules, because if you do modules and your library that you need is not available as a module, basically library is useless. So the expectation is that sooner or later, everyone in this world will be just building Java modules. And this is where the thing about new and not new comes. So everything below that line is actually new. There was no notion of modules in Java itself. The platform wasn't modular. Every time you wanted to run a hello world, you had to package the whole Java thing. Now that changed. The whole thing above that line is totally not new. It's not new in the sense that if you were in a situation that you had to do, or if you wanted to do modules before, you could do so. There was nothing preventing you from doing so. There was a system in place that allows you to do this for over 10 years. So conceptually, there's nothing new in that space as far as your options are concerned, as far as what you could do. So this is what's going on right now. A lot of people discover that, the world is not as pretty place as they thought it is. So now we go back to keep it simple. And the question that you want to ask yourself is, when keep it simple is not enough? Because it's a good idea, okay? Let's make it easy for developers. Let's keep it simple. Let them, just sit down, write a bunch of things, and run modular stuff. Well, it's not always the case. It's not always the case, and to illustrate that, I'm going to use an analogy which we often use in software development. We compare building a product to, building a program to building a product. So when you build a product, you start from a material. You got some materials, you produce some intermediate products out of them, then you combine those products, and at the end of the day, you end up producing your product. So let's say you want to produce a robot like this. What you're going to need is bunch of things. You're going to need some software for that. You're going to probably need some tools. You're going to probably need some hardware, maybe some wiring. You probably need computers. So those are the things that someone produces and gives to you in order for you to be able to do your job. If you think about it further, though, those guys that produce those things for you, they also need some other things that someone else produces and gives them so they can do their job. So we end up building this kind of the dependency graph thing. And if you think about this dependency graph, there's something terribly wrong with it. And what's wrong with it? It's acyclic. It's beautiful. It's like we programmers would create it, like, because we like that thing. We like simplicity. But if you were to draw this as it appears in the real world, I bet you would probably draw an arrow between every two nodes in that graph. Because the guys down there producing tools, they are probably using computers, and those are probably using software and so forth. So essentially, the world, it's not that simple. What happens in the real world is we have to have 2, 3, 5, whatever entities to come together, agree on a thing, to get the job done. That's what happens. It's not so simple like I depend on you and you depend on that other guy. But because we're developers and because we want to keep things simple, we're just going to draw the world as a unified, like a cyclic graph. So to kind of simplify that thing, so you have entities, and these entities offer you something, and other entities is using that something, and at the end of the day, put everything together and produce a product. That is exactly how we think we build applications. We have artifacts. Artifacts export some functionality. We use that functionality in another artifact. At the end of the day, put all these artifacts, build our application. So with that analogy in place, let's compare the two solutions that we have in different levels. So that's level 2, where you try to decouple yourself from the artifact. In order to decouple yourself from the artifact, you need to provide an ID. And you need to say, I don't really want the jar file. I want any jar file with that ID. OK, and SGI, you can do that in the manifest.mf files. And Java 9, you can do that in module info Java. Now, your artifacts, SGI are plain old jar files. In JSR 376, you could either use jar file or JMod. That's a new packaging thing for Java 9. I'm sorry. So that's pretty simple. That's almost identical. With one tiny little difference, to which I'm going to come back later. There is no notion of versioning those modules in Java 9, which means if your artifacts change over time, there is no way for the system to know which version of that particular artifact you want to use. And why is that a problem? We'll see in a second. So level 3, if you want to go one step further, you want to decouple yourself from identity. So before that, you depend on this other ID, spring whatever, or spring whatever, or hibernate or something. That's the ID. You don't really tell what exactly from that thing you want to use, but say, I want that thing. Now, you want to go one step further, and both frameworks allows you to do this. In OSGI, you would just say export package. So this is the provider side. The provider describes what they produce for you. So basically, they say, come my company, my package is what I'm giving you. Oh, by the way, I do have a lot of other stuff in this box, but you're not allowed to touch it because that's my internal stuff. Right? Same thing goes with modular info. You just say export, provide a package. So that's pretty much identical. The difference comes on the other side, when you try to tell what is it that you use. Now, historically, those of you that know OSGI may recall, there was a header known as require bundle. And in that require bundle, you put the name of another module, and you basically say, my module depends on that other module. That is essentially what Java 9 gives you. It gives you requires other module. So you now depend on the provider of the thing that you actually need. And you may think, OK, why is that even bad? And boy, how OSGI handles that? Well, OSGI nowadays uses import package, which basically tells the framework, I care about that thing. I don't really care who produces it or where it comes from. As long as someone is able to give me that thing, I'm good to go. And there's a fundamental difference, which I was struggling to explain to people until a recent blog post showed up on InfoQ by Neil Bartlett and Kai Hagbert, who put those two images on it, which clearly explains the situation. Why is that a problem? So that is the first. So before, you have a module A and module B, and you typically say that a package in module B needs a package from module A. In the other scenario, you have a module A and module B, and you say module B needs module A. And it's all good. Now, over time, you realize that your package, your module A has become too big, and you want to split it into two modules. So you have now A and A prime. And then you split the packages. Half of the one package goes to the one A, the other one goes to the other A. Now, in the first case scenario, because your relationship is defined on a package level, if you just put these two modules in the runtime, it all works together because no one cares where they come from. It just cares that they're there. But if you only have a package relationship, now you don't know. Do you need the old A, or do you need the new A? Or do you need both? Oh, wait a minute, you can't have both because the system restricts you from having more than one package with the exact same ID. So you all of a sudden in a situation, and you don't have versioning. So from that perspective, you're all of a sudden in a situation where you don't really know what are your dependencies. That put into the human environment would go like this. In OSGI world, you would say, I need a power plug. I don't care who provides a power plug. As long as someone gives me a power plug, I'm good to go. In Java 9 world, you would say, I depend on foo because I, as a developer, know that foo produces power plugs, and I, as a developer, know that foo is the only thing allowed in this world to produce power plugs. And the significant difference is who knows. Down here, the system knows. Now, up here in Java, it's you that you need to know. And every time things change, it requires a developer intervention to actually change things, to actually tell the system, oh, by the way, now you need those other things. Okay, so that is a significant difference. The require bundle thing, it's something that still exists in OSGI, but it's not used. It's something that caused so many troubles over the years that any OSGI developer nowadays is going to tell you, stay away from that. Don't even think about using it. The other thing is versioning. So in this case, I can actually say, well, I know power plugs change over time, so what I need is actually a power plug that was produced between version 2 and 3. There's no notion of that in Java 9. So you basically need to know, you as a developer, need to know that this module that you use actually uses a specific implementation, specific version, even though it's not in the API, and you know exactly which version of the module you need to put on the module path, because system will not help you in any way. So that is one significant difference. And the other thing is, what if you use things from someone else, and then you give things to someone? Do they need to know what you have used? Now, in some cases, they need. Because, for example, say I'm producing a computer, and I bought a power plugs that I use to power my computer. So if my customers want to change that power plug, they need to know which power plug is compatible with the computer that they bought. And in OSGI world, you can say it uses whatever power plug, versions, and so forth. So you basically give them this information. Now, how they're going to use that information, that's up to them. In Java 9 world, you basically tell them, well, guess what? We use the foo module, right, which produces power plugs. And because now you bought a computer from us, you also depend on foo. So you introduce a transitive dependency for the customer, whether or not he is actually interested in that. And that, in many cases, actually renders to be a significant problem. So if you think about level 3, you see that there's some things covered, but not really decoupled from identity. You're still tied to the identity of the thing that actually provides stuff to you. Okay, so let's go one level up. That's level 4, where you actually want to decouple now from the implementation itself. And for that to happen, you need to be able to negotiate things. You need to be able to say, I need those things, and find me someone who can provide those things. Now, how do you do that in OSGI? Well, in OSGI, you have this thing known as a resolver. And resolver is the one that looks for these two things known as requirements and capability. So every time you create an artifact, you can say, this artifact has these requirements. So you can say, I require to be able to do this, and on the other side, you have another artifact that is saying, I can do this for you. So for example, you can say, you know what, I need, for my device to function, I need to be connected to a power outlet. Or actually, I need power. I need someone to power me up somehow. You don't really say, I need a power plug, because power plug is just one of the ways that you can get power. But as long as someone powers you, you're good to go. And then some other thing comes in and says, oh, I can do that. I can give power to different things. So now the resolver goes like, oh, you need that, and this guy can do that, so let me hook you guys together, and you go and do this and get the things done. How do you do things like that in Java 9? Well, you can't. There's no notion of a resolver whatsoever. It could be probably done by some external system, by some external tooling. It may be partly needed by Java EE, and maybe something be implemented in Java EE, but that's just me saying that maybe. No, service loader is going to be actually on level 4 or 5, next level. I'm going to talk about that. This here is wiring artifacts. This is basically replacing your Maven dependencies. Instead of saying, I need Spring, you say, or instead of saying, I need JAX-RS for my application to work, you will basically say, I need something that is capable of serving RESTful services. I don't care what it is, as long as it complies with this contract, right? So this is on the artifact level. But that's a good question, which leads us to next level. So you see, it's very basic on level 4. This is level 5, where you have the service registry in OSGI, which is a concept where you create kind of similar concept to requirements and capabilities model, except here you're dealing with your application internal. So you just register a service. When you register a service, you provide a lot of metadata, or as much metadata as you need, and you say, this is my service, it fulfills this contract, and it can do those things. And then some other service, instead of being directly dependent on your service, can actually go to service registry and say, okay, give me someone, or give me everyone, or give me a list, but filter through those criterias. Give me services that can do these things. And then you get the references, and then you can do whatever you want with that. You can't do that in Java 9. You can use a service loader. How many of you are familiar with a service loader in Java 9? How many of you know it exists? 1, 2, 3, 4, 5, 6 people in the whole room. So for your information, service loader is not a new thing. It's been around, I think, I may be mistaken, but at least since Java 1.4. Is it? Okay, I was thinking it's before. Okay, so thank you. So it's Java 6. So it's not that old, but still old enough. And in the whole room, we have like 6 people that are aware of it. Now, what happened in Java 9 is they moved the service loader into the module definition, so it now is aware of modules. But functionality-wise, it can be used the same way as before, which is telling basically, this is my service, please inspect the jar file and load it for me. And there's no notion of service registry, there's no notion of filtering services, or any of those more complex things that you may want to do to fully decouple yourself of ownership and time. Especially, there's no notion of dynamism in Java 9, so you cannot, once you load a service, it cannot go away. It's there for the life cycle of the application. Well, that's not entirely true. There are layers, a notion of layers in Java 9. You can remove things from layers, but it's a lot more complex than just a simple service registry. So those are roughly how things compare. And if you want to go in more details, obviously, I'm just scratching the surface here. If you go deep into details, you may figure out that, okay, you can actually do some things to some extent. But as you can see, there are problems that were solved over the years, which still appear to not be solved in Java 9. And then this brings you to the question, okay, if those are known problems and they did it the way they did it, I mean Oracle and Java, does that mean that they did it wrong? Did the whole modularity wrong? And the answer to that is no, they didn't. And the reason why answer is no is this. It all depends how you want to define modularity. So when they wanted to do modular Java, they were talking about Java platform. They wanted a modular Java platform, and they did that, and they did it very, very well. So as far as Java modular platform is concerned, I have nothing against that. I actually very much like what they did. The problem is when you try to introduce, okay, and by the way, this is like a copy from a Jigsaw site, I believe, with the goals that Java modular needs to, the problems that needs to be resolved by the Java modular system. And all those are resolved. If you look into what they do with Java 9 and Jigsaw, they solve the problems that they wanted to solve. So it's all good. Level 5 modularity was never one of those problems. Okay? Now, the problem for me becomes when you try to introduce that exact same solution that you use to build a modular platform for building applications, because those are two totally different concerns. Building a modular Java platform is a totally different concern than building a modular Java application, right? And it requires different thinking. So I think the whole problem is trying to map those one-to-one and trying to tell people, okay, so look, we did it for the platform, so that means it should work also for your application. It may or may not. Now, a lot of people in the OSGI community believe that that's actually a good thing, because when people start using modularity in Java 9, they will realize how limited it is, and they will start looking for better solutions, and therefore they're going to go to the OSGI. I'm honestly not quite sure this is going to happen, but it may. Just to let you know, you have an alternative if you want to. The final question that I want to address today is, and that's a question that I've been asked a lot, is, okay, you have these 5 levels of modularity, but do you need them? Do I need to build my application at level 5? No, that's the answer. You can stick with level 1 if you do hello world. You can go anywhere in between level 2, 3, 4 if that's what fits your business requirements. Remember, at the end of the day, you're building an application to solve a particular business problem. So you choose the right technology for what you need to, what your business problem is, what your business case is. It does not mean that every time you start building a Java app, you need to go all the way level 5 with dynamism and everything, because it obviously may not make sense. Where it makes sense when you want to acknowledge the fact that you don't know things. The essence of modularity is not knowing. If you are building application where you expect requirements to change, and you expect that your application needs to be easily in a situation to adapt to new requirements, that is, replace part of it, change an implementation logic, introduce something else, then you need to acknowledge the fact that things will change eventually and prepare for that. That is the case with the company that I work for, which is called Liferay, and we historically produce what was known as a Java portal. Today is more of a Java platform for building applications. That thing is pretty big. Where is the lines of code? I believe it goes like some, don't see the number from here. 10 million, no, 6 million lines of code or something like that. That's a pretty huge beast. It's a product that is widely used in big enterprises. And at some point in time, it's built as a monolithic application. It was built as a monolithic application. And at some point in time, we hit the ceiling. So that's it. We cannot do anything anymore with that beast, because every time someone touches something, something else breaks on the other end. So the question was, how do we do with that thing? Okay, microservices is the obvious answer that everyone's going to scream, except we are not building this for ourselves. This is a product that we offer to other people. And right now, it's totally based on Osgi. It's still delivered as a single platform, except it contains over 100 apps, over 600 modules, and 2,500 microservices. So if we were to choose a microservices architecture the way that everyone's talking about today, imagine us going to a customer and trying to give them that thing and tell them, oh, no, that's all good. You'll figure out how to manage it. That would never work. So but on the other hand, we have all kinds of customers. We have customers in telcos, in banking, in universities. They do whole different things with that platform. There's no way for us to know at the time we're building that platform, how would they use it? Because all of them is going to use it in a whole different way. So the only thing we could do is we could try to build it in a way that is as modular as possible and as adaptable as possible. Just to give you a few examples, this is an example of requirements and capabilities usage. So if you want to build a REST service and deploy it on Osgi, you basically just say, you require capability, that's Osgi contract, Java JAX-RS version 2. And you say, oh, that's a lot of code. Well, you don't have to write this. There is tooling around that actually does this for you, as long as you put the right thing in the right place. On the other hand, if you want to say, okay, Liferay, I do appreciate that you can serve REST services, but I don't like your implementation. I actually want to use this other thing that serves RESTful services. You just put your implementation in the system and say, provide capability Osgi contract. That's it. Those are my dependencies, version 2. And you could have as many implementations of the contract as you wish, as many clients of that contract as you wish, and you can change them at any time, no downtime required. Now, another example is how we use the service registry. So this is basically using a component framework known as declarative services. But there are a bunch of other component frameworks in Osgi which you may or may not want to use. So this uses annotations. So you put add component and basically register something as a service, which goes to the service registry, which means if your client to that service uses totally different component framework, can still get that service. That is, for example, if you build your services with Spring, and you try to use them with juice. You can't do that because you have two frameworks that are non-interoperable in any way. Right here, you have that problem because you have the main service registry where everything is registered, and it doesn't matter which technology you use to actually register or search for a component. So the flip side of that is at reference annotation, in which case you could say, I could just put at reference, and that's going to give you a service. Or you can actually define how you want to reference that service. For example, you could say, okay, the cardinality is multiple, meaning I want every single thing that implements that contract. And it's dynamic, meaning I'm okay when things change. They go away and show up during the life cycle of the application. And the policy option is greedy, meaning even though you have wired me already, if things change, please let me know and rewire me again. So, well, you can leave any of these out or change the options. So that gives you the flexibility to decide. You as a developer decide, do I want to be statically wired to that other thing once forever until the application is stopped? Or do I want to react to changes? All right? It's your choice. No one tells you, oh, that's the framework, that's how you should do it. You decide whether it makes sense or not. That thing allows you to optimize for predictability. So obviously you cannot predict everything. There's things that may happen and will happen that there's no way for you to predict them. But there are fair large amount of things that you can think of that, well, you know what? We provide this service, but maybe someone would want to actually have more or less. Okay, let's make it a service. Let's register. Let's make it dynamic. Let's allow people to search for that service, right? So you optimize for things that can change over the lifetime of your application, and that is what is called, what I call, an application agility. Now, you talk about agility every time you go to a Agile conference, and this typically refers to a process. How you build software, how you organize teams, how you, stand-up meetings, or all the other buzzwords. So we're so obsessed with agility when it comes down to teams. But our applications that we build are static. They're built with this mindset, they start, they establish a state, and that state will never change until we shut them down. And that's okay for a fair amount of applications out there, but for a fair amount of applications out there, it's not okay. So if you are in this use case where you actually need your application to be dynamic, to react to changes, then you want a more dynamic modular framework. Thank you. One shameless plug at the end of the presentation. We do organize a conference called ModConf, which is actually next week in Germany. So if you want to hear more about modularity, feel free and welcome to join us there. Thank you. And I think we still have 12 minutes for questions. Anyone? I barely can see, but if you raise your hand and I don't see you, shout. Okay, I think no questions. Okay, you can come see me after the presentation or outside. Or you can come down to our booth, although it's probably too late already. Thank you, guys.